handout logical form does. And that is where you have multiple occurrences of a variable. So let us use a single example. Here is a very simple sentence form. P horseshoe squiggle P. And now let us look at 4 or 5 sentences. A horseshoe squiggle B. A horseshoe squiggle A. Squiggle A horseshoe squiggle A. Squiggle A horseshoe squiggle squiggle A. And squiggle squiggle A horseshoe squiggle squiggle A. And ask of each of these sentences whether they are substitution instances of that form. But before you can do this, you have to add to the algorithm the following. Once you've cycled through all of the truth functions in the form, you now ask, suppose you've cycled through all of the truth functions in the form and they all match up in the sentence. Now you have another question to ask. Are there repeated occurrences of at least one variable? Yes, P occurs twice. And now here is what you need to say in the algorithm. Whatever goes into the first occurrence of P must go into every subsequent occurrence of P. If you have something different going into a subsequent occurrence than you do the first occurrence, it cannot be a substitution instance. Okay, look at this form, P horseshoe squiggle P, and the sentence A horseshoe squiggle B. Let's go quickly through it. Horseshoe, horseshoe, good. Squiggle, squiggle, good. We cycle through all the truth functions. Now, are there repeated variables? Yes. What went into the first occurrence? A. What goes into the second occurrence? B. The same or different? Different, no good. Okay, let's move to sentence number 2.
Yes.
Horseshoe, horseshoe, squiggle, squiggle. A goes into P. A goes into the second occurrence of P. Good. Now a hard one. The third sentence, squiggle A, horseshoe, squiggle A.
Yes.
Horseshoe, horseshoe.
Yes.
Good. Squiggle, squiggle. Good. Squiggle A goes into the first occurrence,
Yes.
but you only have A to go into the second occurrence. No good. Okay, sentence 4. Squiggle A, horseshoe, squiggle, squiggle A. Horseshoe, horseshoe, good. Squiggle, squiggle, good. Squiggle A goes into the first occurrence. Squiggle A goes into the second occurrence. Good. The last sentence. Squiggle, squiggle A, horseshoe, squiggle, squiggle A. Squiggle, horseshoe, horseshoe, good. Squiggle, squiggle, good. Squiggle, squiggle A goes into the first occurrence, but you only have squiggle A to go into the second occurrence. No good. I suggest you write that on a piece of paper and make sure you understand why those answers are as they are, because for quiz 3, you can guarantee that there will be repeated variables is not a substitution instance of that form. But now with this extra refinement of the algorithm, by adding the extra parameter to the definition of scope size, we can answer the question whether 1 and 2 are substitution instances of the form. So, largest scope, horseshoe, 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 good. Next, largest scope to the left of the horseshoe, dot. Dot, good. Wedge in sentence 2, bad. Sentence 2 cannot be a substitution instance. Okay, finally, next largest scope to the right of the horseshoe, wedge, wedge, and no more left in the form, good. P. Okay, says nothing about that, and that creates problems. But the book also says nothing whatsoever about the following. Okay, take a look at this. Okay, now you can turn it on again. P dot Q, horseshoe R, wedge S. And A dot B, horseshoe C, wedge D. And A wedge B, horseshoe C dot D. Now, if we run the algorithm, let's do that. Truth function of largest scope in the form is the horseshoe. Truth function of largest scope in sentence 1 and sentence 2 is the horseshoe. So far, so good. Now, here's the tricky part. Truth function of next largest scope in the form. It doesn't matter. They have the same scope size. It doesn't matter if you do thing to the left or the thing to the right. Thus, we have to introduce another parameter defining scope size, and that is geographical location. We have to distinguish between a truth function to the left of a truth function of largest scope, which is the dot in this sentence form, and a truth function to the right of the truth function of largest scope, which is the wedge. Now we can answer the question by refining the algorithm to state, once you've found the truth function of largest algorithm, we're determining substitution instances. Step 1, look at the sentence form and determine the truth function of largest scope. It is the horseshoe. Step 2, look at the sentence and determine the truth function of largest scope. For sentence 1, it is the horseshoe. If they are the same, continue. And they are the same, horseshoe. If they are not the same, stop, no substitution instance. So in sentence 2, the form has horseshoe, largest scope. Sentence 2 has wedge, largest scope. They are not the same truth function. Stop, no substitution instance. Now, you just iterate, cycle through. Go to the truth function of next largest scope in the form, which is the wedge. Go to the truth function of next largest scope in the sentence, which is wedge. Are they the same? Yes, continue. Continue until you've run through all the truth functions in the form. If, when you've run through all the functions in the form, they are the same as the truth functions in the sentence, then you have a substitution instance. If at any stage when you cycle through the truth functions in the form, they're different from the truth functions in the sentence, you do not have a substitution instance. And that's all there is to it. Very simple. Okay, so a sentence, in order to be a substitution instance of a sentence form, must have all of the truth functions that the sentence form has. So if a sentence has fewer truth functions than the sentence form has, it cannot be a substitution instance of that sentence form. But not only must a sentence have all of the truth functions that the sentence form has, they have to be in the right place. And to see what that means, let's look at this example. P horseshoe, left parenthesis, Q wedge R, right parenthesis. Okay, that's our sentence form, and here are two sentences. A horseshoe, left parenthesis, B wedge C, right parenthesis, and A wedge, left parenthesis, B horseshoe C, right parenthesis. Notice, both of those sentences have one horseshoe and one wedge. And the sentence form has one horseshoe and one wedge. However, only one of the two sentences is a substitution instance. The first one, A horseshoe B wedge C, is a substitution instance of P horseshoe Q wedge R. But the second sentence, A wedge B horseshoe C, is not a substitution instance of P horseshoe Q wedge R. Even though the second sentence has all of the truth functions the first has, they're not in the right place. Look at the form. The last thing we did was to horseshoe. In the sentence number 2, the last thing we did was to wedge. Thus, the truth function of largest scope in the sentence form is different from the truth function of largest scope in the sentence number 2, where largest scope simply means the last truth function that was used to build the sentence. The last truth function used to build a sentence has largest scope, meaning the number of symbols to its left and to its right. A wedge, B horseshoe C. The wedge has larger scope than the horseshoe. The wedge has to its left A, and to its right, left parenthesis B, horseshoe C, right parenthesis. In the second sentence, the horseshoe, in its scope, just has B and C. So the scope size of the horseshoe in the second sentence is smaller than the scope size of the wedge. The wedge has in its scope B horseshoe C. B horseshoe C is contained in the scope of the wedge. Thus, the scope of the horseshoe in sentence 2 is smaller than the scope of the wedge. So scope is a way of talking about the order in which a width is built. The later a truth function is used in building a width, the larger its scope. So the truth function that was last used to build this. Okay, so let's look at some very basic sentence forms and sentences. And so I'll put 3 up on the board. Here's one sentence form, P. The variable P is a shape a sentence can have. The most general shape possible. Because a variable is a placeholder for any atomic sentence. Thus, any width whatsoever. So any width is a substitution instance of P. Okay, squiggle P has more structure than P. It's an atomic sentence that's squiggled. It's a width that's squiggled. And squiggle P has more structure than squiggle P. So here are 3 sentence forms: P, squiggle P, and squiggle P. Underneath them, I will write in each column 3 sentences from sentence logic. A, squiggle A, and squiggle A. And so the question is whether a sentence is or is not a substitution instance of a sentence form. The sentence forms are here on the top. P, squiggle P, squiggle P. The sentences are below them. For each sentence, is it or is it not a substitution instance of that sentence form? Meaning, does that sentence have the same shape as that sentence form? P, we can put it in a Zen way, is the shapeless shape. It is the shape every width has, because P is simply a placeholder for any width whatsoever. Thus, all 3 of these widths are substitution instances of P. Even though they will have A and squiggle A have different truth values. Shape is not concerned with truth value. A and squiggle A are both substitution instances of P, the variable P. Thus, they have the same shape relative to P. As we impose structure, fewer widths will have that shape. Is A a substitution instance of squiggle P? Okay, look carefully. This has a squiggle. Does A have a squiggle? No, so it cannot be a substitution instance. It cannot have that shape. Does squiggle A have a squiggle? Thus, it is a substitution instance. Does squiggle A have a squiggle? It has 2 of them. But what's the last thing I did to build squiggle P? Squiggle. What's the last thing I did to build squiggle squiggle A? Squiggle. Thus, they not only have squiggles, but in the right place, i.e., in terms of what's the last thing that was done to build the sentence and to build the sentence form. Now let's look at squiggle squiggle P. Is A a substitution instance of squiggle squiggle P? No, because it has no squiggles. Is squiggle A a substitution instance? No, because it doesn't have enough. Is squiggle squiggle A a substitution instance? Yes, it has enough. Okay, you can, yeah. Go ahead. Okay, now we're going to put some parentheses in. I'm just making these up. Let's see. Okay, so we have A or B, or A, horseshoe B. So the first thing we do is fill in, and so there are two atomic sentences, A and B, meaning 4 rows. The first thing we do, fill in the columns underneath A and B. So that would be T, T, F, F. And fill in all of the A's first. And then the B's, TF, TF. Okay, what's the last thing? What's the last truth function we use to build this with? The parentheses will tell you.
The horseshoe.
The first horseshoe. That's the last thing we did. As you know, once you have identified the last truth function you used, you can, it doesn't matter, fill in the columns to its left first, and then the columns to the truth functions to its right second, or the columns for the truth function to its right first, and then the columns for the truth functions to its left second. It doesn't matter. Once you know what the largest truth function is, i.e. the last truth function you use to build the sentence, you can do everything to the left first, and then everything to the right, or everything to the right, and then everything to the left. And that's true as you go down. So in here, the width to the left of the horseshoe, I have parenthesized A wedge B, and then I've wedged that to A. Okay, once I figure out what the last thing is that I did, then I can do anything to its left first, and then everything to its right. In this case, it doesn't matter. The wedge, the second wedge, is the last thing I did. Okay, so let's fill in the width to the right of the horseshoe, which is A horseshoe B. And that's easy to do. You just need to know the truth table definition of the horseshoe. You just read it off. T horseshoe T is T. T horseshoe F is F. F horseshoe T is T. And F horseshoe F is T.
How is F horseshoe T?
Well,
if it's an F, the premise is false.
that's in the book, and then I explained last week why we have a T rather than an F. The book does not give you a good, the true explanation, which I did give last week. I think that you have that. We'll talk about that. There may be a video of that. Okay, now the width to the left of that horseshoe, we have to fill in the columns. The second wedge is the last thing we did. So the first wedge is what we do next. And that too, we just read off the truth table for the wedge. T, 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 F. And now we're wedging T to T, which is T. T wedge T is T. T wedge F is T. F wedge F is F. Finally, we are going to horseshoe the column underneath the wedge to the column underneath the horseshoe. T horseshoe T is
T.
T horseshoe F is T horseshoe T is
T.
F horseshoe T is
T.
and the column underneath the horseshoe is TFTT, and that tells us the truth value of the entire width. And that finishes the construction of that truth table. So let us put on the board some truth tables, and the first one, I'll use atomic sentence letters as opposed to variables when I write these, when I write these down. Okay. So that's A horseshoe, left parenthesis B, if and only if, left parenthesis, squiggle B, wedge A, right parenthesis, right parenthesis. Okay, step one, count the number of distinct atomic sentences. How many different atomic sentences are there? Two. Just A and B. When B recurs, that's not a new atomic sentence. Okay, so step two, determine how many rows there will be in your truth table. 2 to the 2 is 4 rows in the truth table. Step three, fill in the columns underneath the atomic sentences. So under the first occurrence of A, it would be TT, FF, and then every other occurrence is the same, TT, FF. Under B, it's TF, TF. and then nice and neatly, you all have lined loose leaf, so you don't have to do this. Separate the rows with a horizontal line.
Why?
Yes?
Why is it TFTF?
Why is it what?
Why is it TFTF?
Oh, well, we went over this last week. Those are the four possibilities for assigning two truth values to two atomic sentences. So TT, TF, FT, and FF. There are no other possibilities. That exhausts them. But I explained last week that this actually is a Boolean tree, and I showed how to do it for 8 rows. But it's pretty easy to see there are no other possibilities left as to assigning two truth values to two atomic sentences. So that is an exhaustive and unique assignment of two truth values to two atomic sentences. Okay, now that we've done that, the next thing is to fill in the columns underneath the truth functions. And to do that, we need to know the order in which we applied the truth functions to build this sentence. Sometimes the best thing to do is to look at what was the last truth function. And you can tell by parentheses what was the last truth function used to build this sentence. The horseshoe, the first horseshoe. We took A and horseshoed it to this whiff, B, if and only if, squiggle B, wedge A. So that will be the last column to fill in. Since there are no truth functions to its left, we need only to look at what is to its right. And now, the same question. What's the last truth function in the whiff to the right of the horseshoe that we filled in? Or that we applied to build this whiff? What was the last thing we did? The parentheses will tell you.
If and only if.
If and only if. So we will do that last while we are within those W's, you know, they're tongue twisters. While we are within this whiff to the right of the horseshoe. So now, to the right of the triple bar, we have squiggle B, wedge A. What did we do last? The squiggle or the wedge? The wedge. Because we squiggled B and then wedged it to A. So squiggle is the first thing to fill in. And that's easy to do because that just flips the truth value. So squiggle T becomes F. Squiggle F becomes T, squiggle T becomes F, squiggle F becomes T. And now we will wedge the column underneath the squiggle to the column underneath A. So F wedge T is T. T wedge T is T. F wedge F is F. T wedge F is T. So the column underneath the wedge now gets triple barred to the column underneath B. So T triple bar T is
T.
T. F triple bar T is
F.
F. T triple bar F is
F.
F. F triple bar T is F. Okay, so now we have underneath the triple bar the truth values of that entire width to the right of the horseshoe. And so we need to horseshoe this column underneath the triple bar to the column underneath A. And so we get T horseshoe T is
T.
T. T horseshoe F is
F.
F. F horseshoe F is
T.
T. And F horseshoe F is T. So the column underneath the horseshoe is the column which gives us the truth value of the whole width. And that finishes the construction of this truth table. Okay, I think that's good.